Hey everyone. Okay, let's go over some of the exercises that I assigned. So let's start with section 9.1. Calculate the periodic rate of interest. So the I, if the nominal rate or the annual rate, nominal and annual is the same thing, just a different name, is 6%. And if you remember in the formula, the 6% is represented by J. So we have the base formula I for your periodic interest rate equals J, your annual, divided by M, which is your number of compounding periods in a year. So for monthly, we're going to divide the 6 by 12 to give you 0.5% per month. For B, we're going to do quarterly. That's going to give you 1.5% per quarter. And semi-annual is going to give us 3% per semi-annual, or every half year. Okay, so 3. What is the periodic rate of interest? So your I corresponding to 5.4% compounded quarterly. So again, it's your J divided by M. 5.4 divided by 4 is 1.35% per quarter. B, 5.4 compounded monthly, so it's your 5.4 divided by 12 gives you 0.45% per month. So for 5, calculate the nominal interest rate if the periodic rate is. So remember, your nominal interest rate is your J, or your annual interest rate. And we want the periodic rate that's given to us, and that is your I. So again, changing your formula around. If it's your periodic interest rate you're trying to calculate, that's I equals J divided by M. So if we want to isolate the J, we need to multiply both sides. So then that gives you J equals M multiplied by I. So for A, we have per half year or semi-annual. So that represents 2 because it's compounded twice in a year, multiplied by your periodic interest of 3.6%, gives you 7.2% compounded semi-annual. 7.2 represents the annual interest rate, or the nominal interest rate. For the next one, 1.8% per quarter. So we need to multiply that by 4 to give you 7.2% compounded quarterly. And 0.6% per month. Multiply that by 12. And that again gives you 7.2% compounded monthly. Let's try number 9. Calculate the compounding frequency for a nominal rate, your annual interest rate of 6.6%, if the periodic rate, or your I, is 1.65%, 3.3%, and 0.55%. So again, we're changing our formula around in order to get the M, okay, the compounding frequency. It's equal to J divided by I. So 6.6% divided by 1.65% equals 4. Your 6.6%, your nominal rate, or your J, divided by your periodic rate of interest of 3.3 gives you an M of 2. And for C, 6.6 divided by 0.55% is 12. 13. Major credit card company posts a nominal or annual interest rate of 19.99%. It's high, but actually that's not unusual. And a lot of times a credit card company will, the nominal rate is actually in the 20%, 21, 22% interest rate. Determine the compounding frequency if the periodic interest rate is 1.6658 and 0.0548. So again, we're trying to figure out the compounding frequency. So M equals J divided by I. Your 19.99% divided by 1.6658 gives you 12 times per year is your compounding frequency. And if your annual interest rate is 19.99% and your periodic interest rate is 0.0548, your number of compounding, or your compounding frequency, your M, is 365 times per year. So that means that it's being compounded daily. Okay, so let's move on to exercises in section 9.2. What is the maturity value of 5,000 invested at 3% compounded semi-annual for 7 years? Okay. So the first thing we need to do is figure out what our I is. Okay. So your I, your periodic interest rate, equals your annual or your nominal rate, your J, divided by the number of compounding periods in a year. So that's 3% divided by 2. That gives you 1.5%. And that is your periodic interest rate. And then remember to take the question and write out what you know. Okay, so even before calculating what the I is, I'd go and say J equals 3%. Number of years is 7. The maturity, what is the maturity value of 5,000? So you know that's your present value. We don't know what the future value is. Okay, and so I'd write out FV question marks. Then you know what you're solving for. So we figured out what the periodic interest rate is. It's 1.5%. So we know that in order to figure out what the future value is, it's equal to your present value multiplied by 1 plus I to the power of n. So that's 5,000 multiplied by 1.015 to the power of 14. So remember, do your brackets first, which is done here, and then to the power of 14. So you want to put 1.015. Click the the y to the power of x button. Okay, so find that on your calculator, push y to the power of x. Then you're going to put in 14, and then you're going to hit equals. And that's going to give you what that factor is. Multiply that by your 5,000, and it's going to give you 6,158 and 78 cents. Okay, so number 5. Assume that 10,000 can be invested. Assume that a $10,000 investment can earn 3% compounded quarterly. What will be the future value after 15 years, 20 years, 25 years, and 30 years? So again, what do we have? We have the present value is 10,000. We know that our J, our nominal or our annual interest rate, is 3%. It's going to be compounded quarterly, so therefore we can figure out what our periodic interest rate is. I is equal to your J divided by M, and that gives you 0.75%. So we're going to fit that into our equation. So we need to figure out what our M is. So it's going to be, for the first one, it's going to be your quarterly, so 4 multiplied by 15 years. B is 4 multiplied by 20 years. C is 4 multiplied by 25 years. And D is 4 multiplied by 30 years to give you what your N is, or what your exponent is going to be. So we want to multiply each of those out. And then you can see that if it's invested for 15 years, you'll have $15,656.81. 20 years, you're up into the 18,000s. 25 years, you're at 21,000. And 30 years, you're going to have $24,513.57. Okay, so again, this is another very similar question. It's going to be your 4% compounded annual, your 4% compounded semi-annual, your 4% compounded quarterly, and your 4% compounded monthly. So this is going to change what your periodic interest rate is going to be. So you're going to take your 4% and divide it by the number of compounding periods in a year, or in that year. So your first one is 1, your second one is semi-annual, so it's 2. The third one is quarterly, so it's 4. And the fourth one, D, is monthly, so you're going to take the 4 divided by your 12. Then you will have your periodic interest rates. Then in order to come up with your N, you're going to take the number of years and you're going to multiply it by the M, which is the number of compounding periods in a year. So therefore your N is going to be 25, 50, 100, and 300. You're going to put that in your equation because those are the exponents. And for A, for 25 years compounded annually, you're going to have 26,658.36. The second one, because it's being compounded semi-annually, so all the same information, but it's going to be compounded twice a year. So you're going to end up having more, which is 26,915.88. Then for C, it's being compounded quarterly. So again, because it's being compounded more often, so you're earning even more interest on your interest. So for the same period of time, 25 years, you're going to have $27,048.14. And if it's being compounded monthly for 25 years, you're going to have $27,137.65. All right, I'll end the video here and I will create another video for sections 9.3 and 9.4. Thanks, everyone.